All right, thank you everyone for coming to our presentation. We know things are a little bit different than usual for this kind of conference, but we're still grateful to get to gather with you and share content and collaborate virtually. So thank you for coming and welcome to our presentation, Programmable Power in Laser Processes. I'm Tamanna Kamra. I'm the Product Marketing Manager at Astrodyne TDI for industrial and medical markets. So that includes your laser applications. And this I have with me is Gary Mulcahy, who is our Chief Technical Officer. And Gary has like over 40 years of experience in power electronics. And he's gonna be the go-to guy to answer all the questions that you may have about power. So let's get started.
For letting everyone know how old I am. That's great. Let's get going.
How wise you are, Gary. All right, so just a quick overview of the agenda. We're going to talk today about integrating controllable DC power in semiconductor and laser, industrial lasers, and just like some of the things that you want to take into consideration in different solutions available today. I won't go through the whole thing because we're just about to jump in. First things first, who we are. We are Astrodyne TDI. We design and manufacture complex power solutions for industrial and semiconductor capital equipment. And we service very like high value applications such as lasers, beam steering, heat control, motion control, a lot of places where power can get complex and the value is high. So, work in progress, dollar value high, and even applications where lives are at stake. So that's really where we lie. And we have over 60 years of experience in the power industry. We have over 700 employees worldwide. And I want to highlight that out of that 700 employees, 15% or more are engineers or technical professionals. So, we put a lot of value and investment in our engineering and our technical capabilities. We design globally. So we have engineering here in the US and also in China. And we also have manufacturing both in the US and China. So quick overview. Without further ado, let's get into the topic of this conversation, which is programmable power and laser processes. So laser designs require tightly controlled and consistent performance from their power supplies. And in any application, when you're choosing a power supply, we're going to take into account the size, the cost, and your power requirements. But there's other things to take into consideration. So Gary, can you go through what those things are?
Sure, Tamanna. So power supplies for laser and semiconductor applications, it's more than just, as Tamanna said, size, cost, and power levels. The output voltages and precision of what you're trying to do, the control method of what you're trying to retrieve, the control interface that you're using to control the power supply. Power supplies are more often used as part of the tool, so they're not just a static source of voltage. They're actively participating in the tool's processes. The AC power interface and how the power supply works with that. Any physical constraints that are involved with regard to the power supply, and reliability and maintainability. These are generally very high profile applications with a lot of cost and money on the line for performance. So, and we'll drill down into each one of these topics as we proceed with the presentation.
All right. Okay, so the first thing you mentioned is the output voltages. So in laser applications, you can have operational voltages up to 100 volts. And this could not always be serviced by what you find off the shelf. Like it's not always your 48 volts or your 12 volts, but sometimes you need something that's a little bit more programmable. So Gary, can you tell me about the different things that are out there and what else a laser supply might need?
Yeah, so our experience has shown voltages typical up to 100 volts in that order of magnitude, maybe sometimes higher. The power supplies are often used in voltage mode, but many times you also see them used in controlled current mode, where the current of the power supply is controlled and the output voltage just sets a high overhead. One thing we've seen in semiconductor lasers as well is the requirements for high pulse rates or high slew rates on the power supply, where the power supply is required to deliver current pulses at frequencies up to 10 kilohertz or sometimes even higher. And the ability to do that becomes one of the more challenging aspects of this type of application. And we'll speak a little bit more about that as we get later on into the presentation.
Right. Sorry about that. All right, so with your power supply, there's also different kinds of control interfaces that you can take into account. In laser applications, I think typically it's analog or high-speed digital. Gary, can you tell us from your experience, what you've seen and the benefits of either way?
So certainly the typical application has an analog interface where more often than not, it's a 0 to 10 volt signal that corresponds to 0 to maximum of delivered parameter, whether it's voltage, current, or power. Many times in industrial settings, you do see a 4 to 20 milliamp interface that provides a little bit more noise immunity. So that's typically what you see. What we're finding though in newer applications is applications are migrating to a serial digital bus for control. This gives much more power with regard to comprehensive data availability, flexibility, which ultimately can lead to improved process controls. You'll see digital buses such as Ethernet or Modbus, TCP, EtherCAT, CAN bus, or others. Every customer or every application that we see has its own personality with regard to the type of interface that they try to use. One thing that is common though is that these applications are looking for very low latency, very fast response time, less than 5 milliseconds. More often than not, we're seeing less than 1 millisecond these days, such that the power supply can be a near real-time component of a control loop, so that the control loop can maintain proper control of the process in a very quick manner.
Very cool. So I think we talked a good amount about your output requirements and what you would need there. But when it comes to your AC power interface, any kind of industrial application could use input voltages from 100 to 524 AC input. But what else do you need to watch out for on your AC line, Gary?
And so what we've typically seen is these applications generally run at higher power. We're talking 5 kilowatts and above. It's not uncommon to see 20 to 30 kilowatts, especially given the consideration that most laser applications, the power efficiency of the laser is relatively low. So in order to produce 1 kilowatt of output power, you could require up to 3 or 4 or 5 kilowatts of DC power to keep that going. So you'll generally see these supplies operate with higher voltage line, something like a 380 to 480 volt three-phase line. We need to be cautious in terms of how you specify the power supply, because the power supply can actually cause disruptions on the power line that could cause problems in other equipment that cohabitates with your system. Like for instance, if you look back long enough, historically there was phase-regulated thyristors were used to control output power. And they can really take a chunk out of the AC line as they operate. You can see on the left there is a screenshot of an AC line in an actual application where the AC line was very well corrupted by a phase-regulated SCR type of supply operating. So you need to be careful that you don't want to be the one who's responsible for causing other equipment to malfunction. And likewise, if there's other equipment like that in your facility, welding equipment comes to mind, you need to make sure that your system and your power supply is not corrupted by an AC line like that. Certainly newer high frequency switch mode supplies typically operate at much better power factor than you would have seen in the past. I mean, it's thyristor control supplies with power factors at around 0.3, 0.4, and harmonics upwards of 80% of the fundamental line current. Whereas a high frequency switch mode is generally going to have power factors greater than 0.95 and harmonics well below 40%. So you need to keep that in mind. And as I said, the power supply in these industrial environments can have some really difficult AC line conditions that the power supply needs to be able to survive. So susceptibility to utility transients for undervoltages and overvoltages caused by other equipment or other events within the facility must be taken into account if you're looking for extended reliability and time for the equipment.
Okay. So those are, I think we would say, some of the main electrical requirements to take into account. I want to spend a little bit of time talking about the physical environment of your supply and where it's going to operate. So in industrial applications, you'll see a broad range of physical environments, anything from ultra clean to ultra dirty, and there's just some additional environmental factors to take into account. So Gary, can you tell us some of the different environments that you've had to design power supplies for and what you did there?
Well, sure. Certainly for semiconductor processing and other manufacturing operations, you might be in a clean room. So in those conditions, you're not allowed to pollute the external environment. So if you have things that can emit pollutants, and the first thing that comes to mind is a fan and the lubricant on a fan, you need to be very careful on doing that. So you have to watch out for you can't emit pollutants into the external environment. Likewise, there's other environments such as a metal cutting floor where there can be a lot of dust and debris floating around that could cause power supply reliability issues if the power supply ingests that material. So having a supply that does not have impingement of external air on its internal components can be a real advantage in those applications. So alongside those, the environmental contaminants are things like humidity, and humidity, especially in some of the equatorial regions, can really be an issue with regard to power supply reliability. Operational temperature, make sure that the power supply is properly rated for the effective temperature that surrounds the supply and its application. We've seen applications that require out-of-door requirements where there's an IP rating. The power supply has to work in a driving rainstorm and things like that. And the other thing that we've seen lately is altitude, where most power supplies are typically rated up to 10,000 feet, but we've been seeing requirements for cities at higher altitudes than that. And as the altitude goes up, the effectiveness of cooling air goes down. So you need to be careful with that regard as well when it comes to specifying the power supply and understanding the environment.
All right. Yeah. So I think you've highlighted, how liquid cooling can really help in those environments and the advantages of liquid cooling in an ultra clean or an ultra dirty environment. But there's other numerous advantages and benefits to liquid cooling. So can we go through that a little bit more in detail?
Sure, Tamanna. The Astrodyne TDI, we've had well over 30 years of experience dealing with liquid cooling. It started out with military applications way back when, but that certainly has evolved into industrial and medical applications, aerospace applications that we use for liquid cooling. So what you find is that liquid is a much more effective means of removing heat. It's well over 10x the ability to remove heat from a situation than air is. So you can get better heat transfer, and with that, if you're good at your design or effective at your design, you can realize improved power density. In other words, less volume for a given amount of power to be able to support the power conversion requirements. I mentioned earlier about environmental issues where you'd like to not have external air impingement on the electronic components within the power supply. So certainly a liquid-cooled solution or a conduction-cooled solution allows you to seal up the power supply so no external contaminants can get into it, or no internal contaminants can get out of it, support the application. The heat capacity of liquid creates a smaller temperature gradient within the unit. That generally means that your components can run cooler for a given amount of power. And one of the leading things that can improve your reliability is temperature. So if you can keep your temperature down, your reliability will improve. And liquid cooling, we have found, is one of the great aids in supporting a longer life of the power supply. Early on when we started out with liquid cooling, you would find these solutions to be very monolithic, and it would be very difficult to get to size the power supply properly for the application that was going on. So what we've evolved to is to provide scalable solutions for anywhere from low power, but typically for liquid cooling, you'll see it up in the 1 kilowatt plus range, up to hundreds of kilowatts. So you can see Tamanna there holding in her hands one of the 5.5 kilowatt solutions we have. That's a 480 volt input, 60 volts, 5.5 kilowatts output. And you can connect those in parallel or in series to support different voltage requirements. And it gives a very effective building block for realizing ultimate system requirements. Well, the last thing is that, for a liquid cooled solution, they have no fans. And if you're ever in proximity of a high power fan cooled solution, they are loud, especially when they're producing full power. Sometimes it's hard to hear what's going on when you're next to them. So the nice thing about the liquid cooled units is if you can't hear the pump, if the pump is located someplace remotely, power supply is basically silent, which can be a big benefit in some of these applications, especially if you're in a test environment, a semiconductor test environment where people are talking a lot. That liquid cooling can really come into play with regard to just the ergonomics of the unit.
Yeah. And your lasers are already liquid cooled, so adding a liquid cooled power supply is not a lift. If anything, it's helpful in that sense. And Gary, in each of these parameters, you know, we hit on how those things help make a more reliable product. But can you tell us on how you design and manufacture to have a reliable product?
So this is something we've been involved with for many, many years, servicing high value applications where failure really becomes expensive or puts lives in danger. So these reliability critical applications have led us to the understanding that to achieve a reliable product, you need to surround the product from all points of the compass with a process that supports the product's reliability. I mean, it starts with a total quality management philosophy, conservative design margins such that the electronic components you use are reliable, effective design tools to realize those margins so that you, especially in these highly complex supplies that are manufactured today, the design tools really become a great aid in supporting the reliability of the product. You should take into account as part of your design latent failure modes, things that grow with time. Make sure that the types of components you use and the design margins you utilize do not lead to premature product failure due to some sort of a latent failure mode. Effective design verification testing, including highly accelerated life testing, that we have found to be some of the best practices to support a reliable design. Likewise, in production, highly accelerated stress screen testing or HASS testing, where each product is subjected to extremes of temperature and operational parameters that are potentially outside of its specified environment, but within its defined safe operating environment that was defined by whole testing. We found that to be one of the more effective tools to use to supporting reliable product in the field. So what we'll do is we'll take each and every product that we manufacture and subject it to something like a 6 to 8 hour HASS test profile, where we're both doing thermal cycling from 70 degrees to minus 30 degrees with very high temperature ramp rates, along with vibration, along with input power cycling, along with output power cycling, all scientifically designed to expend approximately 1% to 2% of the product's expected life. And that we have found to be a great tool for verifying production process consistency and really attacking early life failures that potentially could happen in the product. That, along with the design that takes into account latent failure modes, has led to some extraordinary reliability performance for products that we've seen. Test process in production with statistical process control has also been a great tool for us, along with ongoing reliability testing. So, our experience shows us that if you surround the product with all of those processes, you have a really good chance of getting a highly reliable product. If one of those processes happens to go away or fails, reliability escapes. I kind of look at it as a fence that you surround the product with, and you need to make sure that that fence is intact completely around the product. And then that's how your best chance of getting a reliable product in the field.
Great, awesome. Yeah, and just to give you guys a little bit more of an idea of power supplies that kind of meet these requirements, I just want to run through the different products that we offer in our standard product portfolio. So up on the top right, we have our Mercury Flex. This is our flagship air-cooled product, and in a 2U 19-inch rack mount, you can actually get up to 15 kilowatts of power from these supplies. So there's 4 modules in that shelf, and each module is rated to 3.8 kilowatts. And under that, we have our Liquid Blade. So that's a liquid-cooled rack mount, 19-inch rack mount, 1U liquid-cooled power supply that gives you 16.5 kilowatts of power. And if you need an embedded solution, we have our Liquid Core, which is a 5.5 kilowatt liquid cool module made for embedded applications more so. And you can, of course, parallel this. All of these you can parallel for higher power needs. And all of these, they're fully adjustable, so they offer up to 500 volts output. You can use them as a current source or a voltage source. We offer both digital and analog control. As Gary had mentioned earlier, I told you just now, our supplies are scalable, both kinds of cooling, and we offer a broad range of global AC inputs. And they're compact, they're rugged, and something that's really neat that I didn't put on this slide is that each and every one of our power supplies that are manufactured go through HASS testing. So definitely have a reliable product here. And to talk a little bit more about, I think earlier, Gary, you mentioned different kinds of high slew rate applications. So what do you do in an application where your power supply may not be able to handle a high slew rate application?
Yeah, so certainly if, look, for instance, in a semiconductor laser, you have a string of light emitting diodes, and in order to increase the current in those diodes, you need to increase the voltage across them. So typically you might have to go from somewhere around 15 to 20 volts up to somewhere around 40, 45 volts to increase the current in those diodes from very light current to very heavy current. To do that quickly, the output voltage of the power supply has to increase quickly. What you find for most offline power supplies, there's a requirement for output voltage ripple suppression that ultimately ends up with a fairly significant output capacitor on the power supply. That output capacitor does not like to slew its voltage quickly. It takes a lot of current to be able to increase the voltage or increase the dVdt on that output capacitor. So what we have found is for certain applications, an offline power supply is really not a great fit with regard to providing high slew rates. So what we developed in response to that was a post regulator. So the offline power supply, any of the supplies that Tamanna showed on the previous slide, can be used as an interface to the AC line, provide a DC, what we'll call a link voltage, and that link voltage will power up a DC to DC converter that's specifically designed for high pulse rates. So it has a very high bandwidth, it has very minimal output capacitance because it's not required to filter out the line frequency signals because they're already taken care of by the offline power supply. And it uses hysteretically controlled buck converters to provide extremely fast response time. You can see on the response that we have all that waveform on the side there. We're able to get from 0 amps to 250 amps with a fairly significant load inductance in a very short period of time, less than 30 microseconds that we're able to drive that. You know, with this sort of a converter, it's very feasible to get pulse rates up to 10 kilohertz or perhaps even higher if necessary, to support applications that really benefit from these high slew rates or high pulse rates. The other nice thing about it is that this using the types of components that are available today, you can get efficiencies on this converter way up. They're well above 97% efficient, so that it doesn't dissipate much power to be able to support the overall mission of the equipment in this particular case, which is to provide a high pulse rate of power conversion.
All right, awesome. So with that, thank you guys. That's everything that we wanted to touch on with the short amount of time that we had. If you have more questions, you can contact us, or if you have any questions right now, we'd be happy to answer them.
Yeah, thank you very much, Gary, and thank you, Tamanna. I do have a couple of questions before we close.
Yeah.
You mentioned your products are air or liquid cooled. Do you offer conduction cooling?
Yes, so we have our supplies are modular and flexible enough to be adapted to conduction cooling, and we have done this in the past. And I think one of the cornerstones of our business is being able to create a supply to adapt to any solution. And so that means we're willing to work with you to give you the solution that you need. And if that's conduction cooling, it's something we have experience with, and it's something that our products can easily adapt to, and we have adapted to in the past. Gary, do you have anything you want to add?
Yeah, so certainly we've seen requirements, and there are sometimes that conduction cooling makes sense, especially if there's already a cold plate involved that's cooling other pieces of equipment in the application. Remember, we only dissipate less than 10% of the heat that's in an application because our power conversion efficiency is generally greater than 90%. So if the rest of the application's already has a cold plate that it's utilizing, having a power supply that can latch onto that cold plate can make sense. Although what our own experience has found is that if you're looking to have a solution where the power supply is somewhat remote from what the actual tool is doing, having the liquid go directly into the power supply is a much more efficient way of achieving cooling. It becomes less space requirements, and it also ultimately becomes less costly because those external cold plates we have found can be quite expensive. And having a well-engineered power converter, which has the heat exchangers inside the power supply, provides a smaller and more cost-effective solution.
All right, thank you very much. How many years have you offered liquid cooling, and in what applications?
Yeah, so we've done liquid cooling for, I want to say, over 30 years, maybe almost 40 years. And I think the first applications were military applications. Also early on, we did semiconductor test applications. But in the last, I would say 5 years, we've deployed liquid cooling in numerous applications like lasers. We've done oncology equipment, so your beam steering, multiple military applications. I don't know if Gary, if there's anything else that's coming to the top of your head.
Well, so yes, certainly we started out with military applications, most likely Navy applications. So Navy has a lot of water to work with regard to cooling. But what we see lately, what we've really been focused on lately is applications in the industrial space, laser spaces, plating requirements, things of that nature. These are applications that heating is another place. These are applications that generally use a lot of power, and the ability to control that DC power to a high degree of precision really improves the process. So this is where all of those parameters we talked about earlier, precision, voltage range, controllability, control speed, come into play. And that's really the bulk of what we've been seeing lately in applications.
You mentioned EMI as you go to higher frequency solutions to address aggressive transient applications. What support can you provide?
Yeah, so alongside our power solution, we're one of the few power companies that also have our own in-house EMI business division, and that's made up of names that you may have seen in the before, such as Radius Power, Filter Concepts, and Gary, why am I blinking? Radius Power, Filter Concepts, and LCR. There you go. Sorry about that. But yeah, so we have EMI capabilities right here in our factory. So we can offer, along with the EMI filtering that we offer within our power supplies, we can offer additional EMI filtering for applications, as well as, PDUs to give you an all-in-one type of solution.
Certainly what we see lately is that, many of our customers really want to focus on what their key intellectual property areas are, what the process that they deliver. So things such as power distribution, power control, electromagnetic interference, those are things that they would really like a partner to work with them on, so that their staff can focus on the things that they do best. And that is really what we've evolved our organization into now, is to be able to be a full service provider, which has both the knowledge, the willingness, the capability, and the product line to provide these types of services for applications. So if it comes to getting the AC power in, distributing the AC power, converting the AC power, providing protection systems, working with the customer to understand all aspects of electromagnetic interference, and providing filter solutions for that. That's really what we're focused on, what we're building the business on.
All right, thank you both. I have one more question. Many of these industrial applications have housekeeping power needs. You addressed higher power, but how do you support the other lower power needs that also need to survive in harsh environments?
Yeah, so to tell you a little bit more about Astrodyne TDI, so the way we operate, we're split into 3 business units. So we let you know about our high power. So that's kind of where I come from, our EMI filters, and we classify as high power as anything over 1 kilowatt, but we have another business division dedicated to lower power needs, which is anything under 1 kilowatt. And they have a broad range of power supplies that can work in harsh environments at higher temperatures. An example of this is our ASM products line. So this ranges from 30 watts to 500 watts in a small form factor, and they operate in a large ambient temperature, I think anywhere from like -40 degrees C to up to 85 degrees. And that's just an example, but there's a whole product line between the EMI, the low power, and the high power business division.
Yeah, certainly as a system designer or an architect, having a toolbox full of high quality capable components, and these include things for bias supplies and low power outputs, as well as EMI filters and the high power converters that we discussed, becomes a very, very effective means for us to provide solutions for our customers, especially since we understand the pedigree of these products. They all go through a similar design regimen with regard to quality assurance and design performance assurance. So that has been, from my viewpoint, a very helpful and effective tool for us in coming up with solutions for customers for complex system requirements.
All right, thank you. That's all my questions for now. To everyone here, if you have another question for Gary or Tamanna or Astrodyne TDI, you can leave it for us in the chat box and we will get back to you. So thank you very much, Gary, and thank you, Tamanna.
Thank you.
Our pleasure.